No doubt after this examination we shall be in a position to offer a few conjectures. Half a century ago, hopes ran high indeed. The unity of force had just been revealed to us by the discovery of the conservation of energy and of its transformation. This discovery also showed that the phenomena of heat could be explained by molecular movements. Although the nature of these movements was not exactly known, no one doubted but that they would be ascertained before long. As for light, the work seemed entirely completed. So far as electricity was concerned, there was not so great an advance. Electricity had just annexed magnetism. This was a considerable and a definitive step towards unity. But how was electricity in its turn to be brought into the general unity? And how was it to be included in the general universal mechanism? No one had the slightest idea. As to the possibility of the inclusion, all were agreed. They had faith. Finally, as far as the molecular properties of material bodies are concerned, the inclusion seemed easier, but the details were very hazy. In a word, hopes were vast and strong, but vague. Today, what do we see? In the first place, a step in advance, immense progress. The relations between light and electricity are now known. The three domains of light, electricity, and magnetism, formerly separated, are now one, and this annexation seems definitive. Nevertheless, the conquest has caused us some sacrifices. Optical phenomena became particular cases in electric phenomena. As long as the former remained isolated, it was easy to explain them by movements which were thought to be known in all their details. That was easy enough. But any explanation to be accepted must now cover the whole domain of electricity. This cannot be done without difficulty. The most satisfactory theory is that of Lorentz. It is unquestionably the theory that best explains the known facts, the one that throws into relief the greatest number of known relations, the one in which we find most traces of definitive construction. That it still possesses a serious fault I have shown above. It is in contradiction with Newton's law that action and reaction are equal and opposite, or rather, this principle according to Lorentz cannot be applicable to matter alone. If it be true, it must take into account the action of the ether on matter, and the reaction of the matter on the ether. Now, in the new order, it is very likely that things do not happen in this way. However this may be, it is due to Lorentz that the results of Fizeau on the optics of moving bodies, the laws of normal and abnormal dispersion and of absorption, are connected with each other and with the other properties of the ether by bonds which no doubt will not be readily severed. Look at the ease with which the new Zeeman phenomena found its place, and even aided the classification of Faraday's magnetic rotation, which had defied all Maxwell's efforts. This facility proves that Lorentz's theory is not a mere artificial combination which must eventually find its solvent. It will probably have to be modified, but not destroyed. The only object of Lorentz was to include in a single whole all the optics and electrodynamics of moving bodies. He did not claim to give a mechanical explanation. Larmor goes further. Keeping the essential part of Lorentz's theory, he grafts upon it, so to speak, McCullough's ideas on the direction of the movement of the ether. McCullough held that the velocity of the ether is the same in magnitude and direction as the magnetic force. Ingenious as is this attempt, the fault in Lorentz's theory remains, and is even aggravated. According to Lorentz, we do not know what the movements of the ether are, and because we do not know this, we may suppose them to be movements compensating those of matter, and reaffirming that action and reaction are equal and opposite. According to Larmor, we know the movements of the ether, and we can prove that the compensation does not take place. If Larmor has failed, as in my opinion he has, does it necessarily follow that a mechanical explanation is impossible? Far from it. I said above that as long as a phenomenon obeys the two principles of energy and least action, so long it allows an unlimited number of mechanical explanations. And so with the phenomena of optics and electricity. But this is not enough. For a mechanical explanation to be good, it must be simple. To choose it from among all the explanations that are possible, there must be other reasons than the necessity of making a choice. Well, we have no theory as yet which will satisfy this condition and consequently be of any use. Are we then to complain? That would be to forget the end we seek, which is not the mechanism. The true and only aim is unity. We ought therefore to set some limits to our ambition. Let us not seek to formulate a mechanical explanation. let us be content to show that we can always find one if we wish. In this we have succeeded. The principle of the conservation of energy has always been confirmed, and now it has a fellow in the principle of least action, stated in the form appropriate to physics. This has also been verified, at least as far as concerns the reversible phenomena that obey Lagrange's equations, in other words, which obey the most general laws of physics. The irreversible phenomena are much more difficult to bring into line, but they too are being coordinated and tend to come into unity. The light which illuminates them comes from Carnot's principle. For a long time thermodynamics was confined to the study of the dilatations of bodies and of their change of state. For some time past it has been growing bolder and has considerably extended its domain. We owe to it the theories of the voltaic cell and of their thermoelectric phenomena. There is not a corner in physics which it has not explored, and it has even attacked chemistry itself. The same laws hold good. Everywhere, disguised in some form or other, we find Carnot's principle. Everywhere also appears that eminently abstract concept of entropy, which is as universal as the concept of energy, and, like it, seems to conceal a reality. It seemed that radiant heat must escape, but recently that, too, has been brought under the same laws. In this way, fresh analogies are revealed which may be often pursued in detail. Electric resistance resembles the viscosity of fluids. Hysteresis would rather be like the friction of solids. In all cases, friction appears to be the type most imitated by the most diverse irreversible phenomena, and this relationship is real and profound. A strictly mechanical explanation of these phenomena has also been sought, but owing to their nature it is hardly likely that it will be found. To find it, it has been necessary to suppose that the irreversibility is but apparent, that the elementary phenomena are reversible and obey the known laws of dynamics. But the elements are extremely numerous, and become blended more and more, so that to our crude sight all appears to fetid towards uniformity, that is, all seems to progress in the same direction, and that without hope of return. The apparent irreversibility is therefore but an effect of the law of great numbers. Only a being of infinitely subtle senses, such as Maxwell's demon, could unravel this tangled skein and turn back the course of the universe. This conception, which is connected with the kinetic theory of gases, has cost great effort, and has not on the whole been fruitful. It may become so. This is not the place to examine if it leads to contradictions, and if it is in conformity with the true nature of things. Let us notice, however, the original ideas of M. Gouy on the Brownian movement. According to this scientist, this singular movement does not obey Carnot's principle. The particles which it sets moving would be smaller than the meshes of that tightly drawn net. They would thus be ready to separate them, and thereby to set back the course of the universe. One can almost see Maxwell's demon at work. Footnote 1. Clerk Maxwell imagined some supernatural agency at work, sorting molecules in a gas of uniform temperature into A, those possessing kinetic energy above the average, and B, those possessing kinetic energy below the average. End of note. To resume, phenomena long known are gradually being better classified, but new phenomena come to claim their place, and most of them, like the Zeeman effect, find it at once. Then we have the cathode rays, the X-rays, uranium and radium rays. In fact, a whole world of which none had suspected the existence. How many unexpected guests to find a place for! No one can yet predict the place they will occupy, but I do not believe they will destroy the general unity. I think that they will rather complete it. On the one hand, indeed, the new radiations seem to be connected with the phenomena of luminosity. Not only do they excite fluorescence, but they sometimes come into existence under the same conditions as that property. Neither are they unrelated to the cause which produces the electric spark under the action of ultraviolet light. Finally, and most important of all, it is believed that in all these phenomena there exist ions, animated, it is true, with velocities far greater than those of electrolytes. All this is very vague, but it will all become clearer. Phosphorescence and the action of light on the spark were regions rather isolated, and consequently somewhat neglected by investigators. It is to be hoped that a new path will now be made which will facilitate their communications with the rest of science. Not only do we discover new phenomena, but those we think we know are revealed in unlooked-for aspects. In the free ether the laws preserve their majestic simplicity. But matter properly so called